This is for Year 10 Methods Pathways. We're going to look at concentration and density problems. So just a quick recap. Density is given by mass divided by volume. Concentration is usually given by mass per volume or volume per volume. So Goulburn Valley, we're looking at question 7. Goulburn Valley carries sediment from erosion from its catchment. Barry takes 5 litres a sample of water from the river, and he extracts 38 grams sediment. What is the concentration of the sediment in the water in milligrams per mil? Okay, so concentration is given by, in this case, mass divided by volume. Our mass is 38 grams per 5 litres water. Now, we don't want to calculate this yet because we want to find it in milligrams per mil. Okay, so we know that for each gram, there are 1,000 milligrams, and for each liter, there are 1,000 mils per liter. So this will be milligrams per mil, which is what we're after. The thousands actually cancel out in this case. So we should get 38 divided by 5, which is 7.6 milligrams per mil. So always look at what your final units are and convert the units accordingly before calculating your answer. So question 8. Milo needs 5 litres of cordial for a party. To make the cordial, he adds 1 cup of cordial to 1 cup of cordial concentrate to 4 cups of water. Then he uses a standard 250 ml cup to measure. How much cordial can Marion make from 1 cup of cordial concentrate? Okay, that's easy because it's 1 cup to 4 cups. So 1 plus 4, 1 cup of water to 4 cups of cordial. 1 cup of cordial concentrate to 4 cups of water. That's 5 cups. B. To make 5 litres of cordial for the party, how many cups of cordial concentrate and how many cups of water are required? It's 1 to 5, so it's 1 litre water to 5 litres. 1 cup of cordial concentrate to 5 litres of water. Okay, so what is the concentration of cordial concentrate in the final solution of cordial? Write your answers in mils per litre. Okay, so concentration is volume per volume in this case. Well, the cordial concentrate in the final solution is 1 litre, and the amount of water in the final solution is 4 litres. Okay, so it's volume per volume, except we want it in mils per litre. So we want the top part to be mils. 1 times 1,000 mils divided by 4 litres. So it's essentially 1,000 divided by 4, which is 250 mils per litre. Okay, that's the final concentration. We'll look at question 10. J has a circular swimming pool of diameter 7 and has a depth of 1.6 meters. Okay, so let's draw a diagram. We've got a swimming pool here, it's circular, and we've got a diameter of 7 meters. So the radius would be 3.5 meters. The depth of 1.6 meters, but J only fills it to 20 centimeters below the rim. So the total height of the cylinder is 1.6, but it's filled 20 centimeters below the rim, which means that it's not filled the full way. It's only filled 1.4 meters above the rim. Okay. So we're trying to calculate the concentration in grams per liters if he adds 2.1 kilograms of chlorine to the solution. So the concentration is given by mass per volume again. Now, I don't know my volume. I need to calculate the volume of water first. So volume is given by area, because it's a cylinder, area times the height. Area is the cross-sectional area. The cross-sectional area of the cylinder is the circle. So it's pi 3.5 squared times the height, which is 1.4. Okay. And my answer would be in meters cubed, because we're talking about volume, and the units we use to calculate volume is in meters. So let's calculate what that is. So I'm going to get my CAS out. And we'll go pi 3.5 squared times 1.4. Okay, 53.8783. 53.8783 meters cubed. Okay, let's use this formula now. So concentration is given by mass, 2.1 kilograms divided by, and I always write the units because it reminds me of what units I'm using right now. 87.83 meters cubed. And we need to convert it to grams per liter. We know there are 1,000 grams per kilogram, and to convert meters cubed, 1 meters cubed is the same as 1,000 liters. So I times the bottom part, 53.8783 times 1,000, and the units of those, that is liters. So we know the thousands cancel each other out, so it's essentially 2.1 divided by my volume, which I can just copy and paste onto the answer. I get rounded to 2 decimal places, 0.04. Okay, so my final answer is 0.04 grams per liter. And that's how you approach these problems. You break it down into what you know and do it step by step, because you want to get the units correct and the units conversions correct. Make sure you write the steps, each step appropriately, so that you have a clear, you can follow your working clearly and to get the final answer. So my final answer is